Progress. It's an inevitable process for every modern city, and with it comes a new set of challenges. Since the 1900s, Palmetto rapidly grew into an industrialized town. The introduction of the railroad brought growth and opportunity for this once small agricultural community whose main crop was tomato. In 1956, the Manatee River, then known as the Oyster River, was dredged and depleted of the inhabiting oyster population. The function of these oysters are to clean and filter contaminants and debris from the water. Industrialization also created problems such as stormwater sheet flowing from a 51-acre catch basin in the north side of town. This stormwater would carry pollutants and debris into the river. In early 2000, the Palmetto CRA had a clear and precise vision for the city and the surrounding waterways. Early on, they took advantage of federal incentives and grants to produce award-winning projects which further incentivized federal funding. The plan was to capture the stormwater and filter it prior to flowing into the river. The Connor Park project fit that criteria. A former Brownsville site, the area was cleaned and decontaminated, then filled with 500,000 gallons of directed stormwater. With a variety of indigenous plants, it removed a significant amount of nitrogen and phosphorus prior to going into the bay. This award-winning project led to more funding in the final portion of the restoration of the river. From its initial vision, architect John Moore designed the layout of these restoration projects. This layout consists of 76 clusters of reef balls. Each cluster consists of 5 reef balls of 3 various sizes, with the largest being in the center, then set 100 feet apart in a grid pattern from other clusters. The reef balls are marked and tagged within the cluster and given a GPS coordinate. These coordinates are valuable for documentation and testing as the months progress. There are 8 main areas within the grid that are used for data collection. These areas are where stormwater filters in and where tidal currents pass through. Once the Florida Waterways and environmental agencies gave the green light to move forward, the Palmetto CRA went to work with coordinated teams. The first order of business was to install pylons for appropriate signage in the navigation channels. These were also deployed with appropriate GPS locations. Coordination was crucial between team members as well as deployment locations. From the manufacturing facilities in Sarasota at Reef Innovations, these reef balls were deployed from 2 different locations upriver to the site. It was amazing to watch Larry Beggs and his team work so rapidly in this deployment process. It was vital that the reef balls need to be installed and acclimated prior to the growing season of the oysters. Climatic conditions also played a vital role as these deployments occurred during the winter months. Once at the site, buoys were placed at the appropriate GPS markers so as it was easily identified by the barges that carried and installed the reef balls.
My name is Ernesto Lazo de la Vega. I'm a biologist. The design is going to be using tools that has been proven. The reef balls. The reef balls are excellent tools for enhancing and growing populations of different organisms, from the filter feeders who attaches to the reef balls to the other organisms who are living and associated to the organisms who live in these reef balls. The amount of reef balls that are planning to put in here is almost 380 reef balls in clusters of 5 throughout a big grid. And the beauty of this project is that the grid will provide us information to later on know where and how the organisms are growing. And as we learn, we can apply this knowledge to other locations for other restoration projects. There's been so many studies putting oysters in aquariums, and we put in some water and determining how long it takes. They range because of range on the size of the oyster all the way to the temperatures and the type of algae. But generally speaking, 30 gallons of algae content of water can be filtered by one oyster. So oysters can filter a tremendous amount of water. One oyster per day, 30 gallons. That's a tremendous amount of water. Ultimately, the Manatee River used to be covered with a lot of oysters. Well, the population of oysters has diminished throughout the years. Thus, their filtration is not there. So what we're trying to do is reestablish new populations, new growth of oyster banks. So they finally will be filtering the water that we need so badly in this river. Now we're going to be doing the first initial inspection of those reef balls by using cameras, underwater cameras, so we can take an outside view of the reef balls and then inside, and then start counting spats, little tiny baby oysters that we're going to be counting. And as the months progresses, as the time passes, we're going to be coming back again every 3 months to continue measuring and counting how many of the spats has been colonizing these reef balls. And as they grow, we'll see the spats growing into bigger shells, and that will be also very important for us to know the growth rate of these oysters under these conditions. This project has a tremendous vision because this environment what we have in this particular area, fresh water from the river and brackish water coming from the ocean, it's a mixture of an environment that we have to learn first before we start applying larger projects with a small scale project that it can expand later on. And as we learn, we're going to be applying these concepts to other locations.
Join us, Ernesto and his team, for video updates with test results of this project in the upcoming months. And as always, the Palmetto CRA would like to thank you for watching.